All right, 3.4 part 3. We're going to start by factoring, and I usually ask myself, is there a GCF, or greatest common factor? Which on this particular problem, number 1, there is no GCF. So I'm going to move on to doing some U substitution, actually. I'm going to substitute an A cubed in for my U. So A cubed squared, like 3 times 2 gives me that 6. I'm just rewriting it all in terms of an A cubed so that I can do my substitution. So everywhere I see that A cubed, I'm going to put a U. So I got like a U squared instead of A cubed squared, 9 times U instead of 9 times A cubed, plus 8. All right, so this usually makes it a little easier to factor. We're usually a little more familiar with what multiplies to be my last number, 8, and adds up to my middle number, -9. All right, so I think I'm going to go with a -1 and a -8. -1 times -8 is my +8. -1 plus -8 is the -9 we have in the middle there. All right, but I originally started with an A variable. I need to go back to the A's. So both of these U's are going to turn into what they're equal to, an A cubed. So I've got an A cubed minus 1 and an A cubed minus 8. All right, and if the 1 and the 8 are not perfect cubes, then great, I'm done. I think both of them actually are perfect cubes though. So that means I've got to use the difference of cubes. So my A cubed minus 1, that would be my A minus 1. And then I've got A squared plus A times 1 is just plain A. Oops. And then my 1 squared, so 1. So that's my difference of cubes. Same thing here, it's just 8 is 2 cubed in this case. So I've got A minus 2, A squared, plus, and then A times 2. I usually put the 2 first, so 2A. And then plus my 2 cubed, which is, or sorry, 2 squared, which is my 4. And that's about as good as it's going to get. You can have them in a different order, but those are my 4 factors. So on number 2, I'm going to start with the same question. Is there a GCF? And actually on number 2, there is. I'm going to factor out a 2 out of everything. In fact, a 2x out of everything. And that gives me 2x out front. I've got an x cubed left. And 250 divided by 2 is 125. And I factored that x out. So now this actually is giving me a sum of cubes. I had a difference of cubes up here. This is a sum of cubes. So let's go ahead and factor that last one. All right, so I still have the 2x, but the sum of cubes is going to factor into the x plus 5. Oh yeah, just a reminder that 5 cubed is 125. That's why I'm using the plain 5 here. And then I've got the x squared minus 5 times x and plus a 5 squared, so 25. All right, and those are broken down as good as it's going to get there. Last one in this section. I still ask myself the question, is there a GCF or is there not? And I'm thinking, I see a t and everything, and I think I can also divide out the -4 or factor out my -4. So if I factor out -4t,
we're going to be playing hide and seek in here, is that okay? Sit.
All right, my 8 divided by -4 is a -2. I took one of those t's out, so I still have t squared. My 60 divided by -4 is a -15, and I took that one and only t out front. And then this one, I still can factor the stuff in the parentheses. In fact, I'm going to do like a u substitution the way I did on problem number 1. I'm going to treat a t squared as a u. So this is something squared is to the 4th. I've got -2 t squared, -15 here. All right, so all of these t squareds I'm going to call a u. So I've got a u squared minus 2u minus 15. That kind of breaks it down into a bit smaller, more manageable pieces here. So what multiplies by negative 15 and adds up to negative 2? I'm thinking I'm going to go with a negative 5 and a positive 3. Negative 5 times 3 is negative 15. Negative 5 plus 3 is the negative 2. And don't forget the negative 4t out front here. All right, and again, my u was a t squared. So both of these u's are going to be replaced with a t squared. So I'm now at negative 4t. I've got a t squared minus 5 and a t squared plus 3. Now I could break it down any further if this was the difference of squares, like if 5 was a perfect square, but it's not. So this actually is as good as it's going to get right here. All right. Now, completing the square, I don't think we've gone through that yet. Here are the steps for completing the square. So I'm going to try to color code this a little bit. Step 1 is to factor out the a. The a is what is in front of my x squared. Their example right here was they factored out the 3, the number that's in front of the x squared. I also have a 3 on number 4 here. That one is out in front of the x squared. So I'm going to factor out a 3. All right, and I'm factoring this 3 out of just the first 2 terms that it says right here. Out of those first 2 terms. When I factor it out, I'm basically dividing it out. So you can put negative 10 over 3 like I divided by 3. And I did not factor it out of the 7. I just did the first 2 terms. Okay, so that in blue, that was my first step. Second step, identify the coefficient of x, square half of this number. Okay, so the coefficient is the number multiplied by your x, your plain x, not the x squared. So the coefficient of that right now is the negative 10/3. They want you to square half of this number. So I'm going to take half of that. Half of 10 is 5, so I got negative 5/3. And they said square half of it. So there's my half of it. Squared is, well, let's see, negative 5 squared is 25, and 3 squared is 9. So 25 over 9. Okay, so square half of this number. There we go. Next up, I need to all right, so then I'm going to do step number 3. You add that number from step 2, my 25 over 9. I'm going to add that in the parentheses, and I'm going to subtract it times the number, the a that's outside the parentheses. So I'm going to put it plus 25 over 9, like it says in the parentheses. Okay, so add the number from step 2 in the parentheses, and then subtract that number. So do the opposite of adding, we're going to subtract it times a. So I'm going to get rid of these guys. My a was a 3, so I'm going to subtract that number outside of the parentheses, subtract my 25 over 9 times 3 though. So let's see, this I can reduce. 3 goes into 9 3 times. All right, so like 25 over 3. There we go. All right, so took care of step 3. And the last step, factor what is in the parentheses and simplify. So the stuff in my parentheses as of right now, this stuff right here, if I factor that, what multiplies by 25 over 9 and adds up to negative 10/3, it actually is going to kind of have a hint in here in the parentheses, wherever I squared, negative 5/3 times negative 5/3 is a positive 25 over 9, and a negative 5/3 plus negative 5/3 adds up to this middle number, negative 10/3. So that actually is kind of my big hint right there. This is going to end up being x minus 5/3 and another x minus 5/3, which if I have 2 of the same thing, that means it is squared. So an x minus 5/3 all squared. I still have this 3 as a leading coefficient that hasn't changed. And then these guys, let's go ahead and combine those. I'm going to do my 7 minus 25 thirds. And if I put it all into one fraction, looks like I get -4 thirds. And it still is equal to 0. Okay. So we did some completing the square. Their overall instructions are to solve the equation. So I still need to go ahead and solve for x here. That means I can add my 4 thirds over to the other side. Okay, I'll put this over here. All right, I'm gonna divide by this 3. It's currently multiplied by that whole set of parentheses. So I'm gonna divide by it. Which dividing by a 3 is the same thing as taking a third of something. So you can write it like that if you'd like. Dividing by 3 or multiplying by 1/3, either way. Same thing, so I get 4/9 right here. And now I'm gonna get rid of the squared exponent by doing a square root on both sides. Nice thing is I do know the square root of 4 and I do know the square root of 9. So I'm gonna get a 2/3 here. And then last but not least, I will add my 5/3 on both sides. They already have common denominators, which is great. So it looks like I got 7/3. Okay, so we have solved for x by completing the square specifically. All right, so let's do this again. Step number 1, I'm going to factor out my leading coefficient, which is a -7 in this case. And I'm just going to factor it out of the first 2 terms. All right, when I factor it out, I'm basically dividing it out. And I leave it a little space there. I still have my -13. I did not factor it out of there. Okay, so I'm kind of leaving the space for the yellow stuff that I had there. My step 2. My step 2 was to take whatever the coefficient of x was. So here's my plain x, not my x squared. The coefficient of the plain x, so -4/7. I want to cut it in half, which -4 cut in half is a -2. So I get -2/7. And then square it. Let's see, -2 squared is 4 and 7 squared is 49. All right, so whatever that number is, I'm going to do the yellow stuff now. I add it in the parentheses. And then I'm going to subtract not just the 4/49, but consider multiplying it by -7. So let's see, get some more space here. I'm going to subtract, like I said, my 4/49, but also times that -7, which that means I've got a negative times negative, so overall addition.
Really?
So I'm going to get a positive, and then 7 goes into 49. 7 times I can reduce this to a positive 4/7. Okay, so I'm going to put plus 4/7. All right, and this still all equals 0, hasn't changed there. Okay, so let's go ahead and factor all of the stuff in the parentheses here. So step number 3, which your big hint for factoring is whatever I squared. A -2/7 is what got squared. So you've got an x minus 2/7 in your parentheses here. You still have the -7 out front. I also still have the -13 plus 4/7. It's kind of messy. That's all right though. It looks like I got -87/7. Okay. So this is now a perfect square. All right, so I still have to actually solve this. So I'm gonna do the green stuff I did before. I'm going to go ahead and add this messy fraction over to the other side. All right, currently, oh, I forgot to square it. It was squared, there we go. That -7 is what I gotta take care of next. It is multiplied by the stuff in the parentheses, so I'm gonna do the opposite of multiplying. I'm going to divide, which is what we did over here. We divided by 3, which is the same thing as multiplying by 1/3. So for me, dividing by -7 is the same thing as multiplying by -1/7. So you can totally do that. So that gives me still everything in the parentheses all squared. I'm at a negative And then 7 times 7 is 49, so negative 87 over 49. All right. This is getting really messy. I need to then do a square root. I'm getting rid of my squared exponent with a square root. All right, which we don't know the square root of 87, but we do know the square root of 49. So this guy, oh, look at this. Small problem, I've got a negative over here, and I'm going to do a square root. All right, so this messy negative number, actually, if I go to take the square root of a negative, there's no solution, no real numbers for this. So we were trying to solve, and I'm going to say there is no solution because of the whole square root of a negative. Okay, so that is a possibility here. They are then asking us on number 6 to solve the previous problems. Oh, this should say 4 and 5. Excuse me, I'll adjust this. Solve 4 and 5 by the quadratic formula. Okay, so if you're using the quadratic formula on number 4, I'll put this down here. My quadratic formula, just as a reminder, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, so it's all about an a, b, c. The a is what's in front of your x squared, the b is in front of the plane x, and the c is the constant. So my a is a 3, b is a negative 10, and c is 7. So I'm going to go ahead and use those in my formula here. Zoom out a little bit. Okay. So x equals a negative b, like a negative 10, so a positive 10, plus or minus the square root of b squared. So my messy, oops, negative 10, there's just straight up negative 10 squared. I would put parentheses around it to make sure your negative 10, not just plain 10, is squared. And then minus 4ac, the a being 3, c being 7, the things I've labeled up here. And then all over 2a. Again, the a is still 3. Okay. So usually I start with the stuff under the square root. I'll put that in my calculator first. I'll get that down to a single number. Just make sure that you use a negative 10 all squared, like in parentheses like that. Just keep emphasizing the parentheses on that one. So I got a 16 under my square root, which I know the square is 16. That's nice. And then 2 times 3 is 6 in the denominator. All right, I'm going to keep simplifying this. Square root of 16 is 4. And whenever I have a plus or minus, that means I get 2 separate answers. I've got a 10 plus 4 all over 6, and I've got a 10 minus 4 all over 6. Okay, so 10 plus 4 was 14 over 6. 10 minus 4 is 6 over 6. All right, so I actually got 2 answers. This I can reduce down. Since they're both even numbers, I can divide them both by 2. I get 7/3. And 6 over 6 is 1, so I actually got 2 answers, 7/3 and 1. Let's see, what did I get up here? Okay, we got the 7/3, matches the 7/3. So where am I missing the 1? Here's the deal. When you do the square root, we need, like we had in our quadratic formula, a plus or minus. So I should have a plus or minus on my 2/3. I treated it like a positive 2/3, got my 7/3, great. If I treat this like a negative 2/3, all right, so I add my 5/3 over. All right, so then negative 2/3 and positive 5/3, negative 2 plus 5 is a positive 3, so I got positive 3/3, which is 1. So there is the second answer we were going for, the 7/3 and the 1. Okay, so just remember, like, this is kind of our reminder here, when you take a square root, make sure we do a plus or minus to get 2 separate answers. So I actually had 2 answers on number 4. Okay, and you can see the same 2 answers with the quadratic formula. So then let's see if I would get no solution on number 5 here. So for number 5, I'm going to do my quadratic formula still. The a is in front of the x squared, b is in front of the plane x, and c is in front of the constant there. So let's see, I've got the same formula, x equals negative b, which my b is a 4. So negative 4 plus or minus the square root of b squared. So my 4 squared, and I emphasized the parentheses on the last one because it was a negative 10 that was squared. In this case, I have a positive 4 squared, so I'm not too worried about the parentheses on this one. All right, so b squared minus 4 times a, which is a negative 7, times c, which is a negative 13. Notice that, again, I put my parentheses around the negative numbers, all over 2a, a being a negative 7 still. Okay, so I'm gonna deal with the stuff under the square root first, like I did last time. So 4 squared minus 4 times negative 7 times negative 13. Looks like I've got a negative 348. All over, and then 2 times negative 7 is negative 14. Okay, but this whole square root of a negative number. Okay, I'm having the same problem that I had on this one. All right, so that means I actually have no solution off of the quadratic formula as well. So same problem, no solution. All right, and then the last question here, how do we know if x plus 1 is the factor of this polynomial? So you actually don't have to factor it to figure this out. Really what I need to do is figure out what makes this factor that I'm considering, what makes that equal to 0. And so if I subtract 1 on both sides, negative 1 is what makes it equal to 0. So let's see if it actually does. I'm going to plug that negative 1 in for both of my x's and see if it makes this equal to 0 or not. That would mean it's a factor or not. So this is what I'm checking out. I don't even have to factor it. Okay, so let's see what this equals. Negative 1 cubed is negative 1. So negative 1 times 3 is negative 3. Negative 1 squared is a positive 1. So positive 1 times 6 is a negative 6. And negative 9 times negative 1 is a positive 9. All right, so it looks like these guys together, negative 9 plus 9 is 0. So yes, because this all equals 0, this tells me the x plus 1 that I was just testing, it is a factor. It didn't give me both factors or 3 factors or whatever. It didn't give me all my factors. It just says that particular piece is a factor. All right, there we go.